So hey guys, welcome back. This is Anmol Shukla and a very warm welcome to my YouTube channel History with me. इंजीनियरिंग फिजिक्स की इस सीरीज में आज की इस वीडियो में हम मोस्ट इंपॉर्टेंट क्वेश्चंस पढ़ने वाले हैं क्वांटम फिजिक्स के पार्ट से। जी हाँ, इंजीनियरिंग फिजिक्स में जो पार्ट है क्वांटम फिजिक्स का या क्वांटम मैकेनिक्स का, इससे जो भी इंपॉर्टेंट क्वेश्चंस बन सकते हैं, बस ये 10 क्वेश्चंस अगर आप करके जाओगे जो मैं आज बताने वाला हूं, उसके बाद उसके आगे उसके बियॉन्ड कुछ भी नहीं आने वाला है। और एग्जाम में इन 10 क्वेश्चंस में से जरूर ना जरूर आपको एक ना एक क्वेश्चन या एक से ज्यादा क्वेश्चन क्वांटम मैकेनिक्स पार्ट में जरूर दिखेंगे। तो क्वांटम मैकेनिक्स के मोस्ट इंपॉर्टेंट क्वेश्चन, सिलेक्टेड क्वेश्चंस आपको देखने को मिलेंगे इस वीडियो में और अगली वीडियो में भी। 5 क्वेश्चन इस वीडियो में और 5 क्वेश्चन अगली वीडियो में, ताकि जो वीडियो है कहीं ना कहीं वो ज्यादा लॉन्ग ना हो जाए। और आपको एक और बात मैं बता दूं कि इस वीडियो की खास बात यह है कि आपको कहीं और जाने की जरूरत नहीं पड़ेगी। यानी कि क्वेश्चन, कई बार क्या होता है, लोग क्या करते हैं कि सिर्फ क्वेश्चंस बताते हैं, उनके आंसर्स नहीं। बट यहां पर आपको क्वेश्चन और उन क्वेश्चन के आंसर्स, चाहे वो डेरिवेशन हो, कुछ भी हो, न्यूमेरिकल हो, सब कुछ यहीं पर मिलने वाला है। तो शुरू करते हैं वीडियो जिसमें हम बात करने जा रहे हैं क्वांटम मैकेनिक्स, इंजीनियरिंग फिजिक्स फर्स्ट सेमेस्टर या फर्स्ट ईयर के मोस्ट इंपॉर्टेंट क्वेश्चंस जो आपको एग्जाम में दिखने वाले हैं। Let's talk about those questions. But before that, if you're new to the channel, subscribe and hit the bell icon to get the daily updates and notification. Also, if you haven't joined my Telegram group yet, specifically for BTech students, please join it. Link is in the description box. प्लीज मुझे मोटिवेट करें, और मैं मोटिवेट होता हूं जब आप लाइक करते हो, कमेंट करते हो और अपने बेस्ट फ्रेंड से, आई एम नॉट सेइंग हर दोस्त से, बट यू कैन एटलीस्ट शेयर इट विद योर बेस्ट फ्रेंड। इतने तो लॉयल आप हो, आई नो। सो लेट्स स्टार्ट टुडेज लेक्चर। So without any delay, let's talk about these selected questions from quantum mechanics. That is the most important questions अगर एग्जाम पॉइंट ऑफ व्यू से देखें तो भी, और समझने के पॉइंट ऑफ व्यू से देखें तो भी। आगे बढ़ने से पहले, इन क्वेश्चंस को समझने से पहले, आई होप आपने इंजीनियरिंग फिजिक्स की जो क्वांटम मैकेनिक्स वाली सीरीज है जिसमें मोस्टली लेक्चर्स अपलोड हो चुके हैं, वो आप देख लेंगे। दिस इज गोइंग टू बी द लास्ट लेक्चर हियर। सो द टॉपिक्स जो वहाँ पर कवर नहीं हुए वो क्वेश्चंस के फॉर्म में यहाँ पे कवर हो जाएंगे। बट इट्स रियली वेरी इंपॉर्टेंट टू क्लियर योर कंसेप्ट, द बेसिक्स। उसके लिए ज़रूरी है कि वो आप सीरीज ज़रूर देखें। डिस्क्रिप्शन में आपको लिंक मिल जाएगा, सो डू वॉच इट। सो now the very first question, which is very basic also, or you know, when we have started this series of engineering physics, the very first lecture where we have talked about, the concept of wave particle duality in quantum mechanics. We talked about the introduction to in quantum mechanics. वहां पर we have already understood this type of concept जहां पर हमने पढ़ा कि light, it behaves like both. Light behaves like particle also, light behaves like wave also. So you can watch that video in detail, but if you're new to the channel, I'm going to explain it again here. Let's talk about it. So the question is, explain the concept of wave particle duality. What is this concept of wave particle duality? And the second part of the question is, how does this concept resolve the classical limitations of understanding particles like electrons and photons? So first look into the first part of the question, जहां पर हमें concept को explain करना है wave particle duality. This is the most fundamental concept in quantum mechanics. सबसे पहले तो you should be clear about this कि quantum mechanics basically it's a field of study in physics where we study about smaller objects, smaller particles. Like we study about electrons, we study about protons, photons, neutrons. We talk about these things. तो यहाँ पर कहीं ना कहीं जो क्वांटम मैकेनिक्स है, हम इन चीज़ों की बात करते हैं क्वांटम मैकेनिक्स में। नाउ दिस वेव पार्टिकल डुअलिटी कंसेप्ट ये कहता है कि जो लाइट होती है, इट बिहेव्स लाइक बोथ। इट बिहेव्स लाइक पार्टिकल ऑल्सो, इट बिहेव्स लाइक वेव ऑल्सो। सो लाइट कैन बिहेव लाइक बोथ। वेव नेचर को अगर हम थोड़ा सा इलैबोरेट करें, वी ऑल नो ओशंस में वेव बनती हैं। आप देखते होंगे ओशंस में किस तरीके से वेव, जिन्हें हम हिंदी में कहते हैं लहरें, लहरें बनती हैं, देन दे स्प्रेड आउट एंड देन दे इंटरफेयर विद ईच अदर। Similar is a manner कि ये particles जैसे electrons, photons, they also kind of spread out and create patterns of interference with each other. And this is being proved in one of the experiment, like Young's double slit experiment. So it's all of these things have been proved. Another thing is particle nature. So at the same time, these particles,
these particles like electrons, photons, they can also behave like very localized object, very discrete object. They can be counted out and detected as individual particles, like a ball bouncing around. माफ कीजिएगा, not bowl, it's ball bouncing around. So what I trying to mean here is these particles can behave. These particles are particles, so they're having particle nature as well, and they are having wave nature as well. Light can behave like both. Light exhibits both nature, particle nature as well, wave nature as well. And that's what the wave particle duality is. So we have understood it for two things. Particle like electrons, photons, they exhibit particle nature as well as wave nature. Light, light particle like electron, photon, they exhibit particle nature as well as wave nature. And that's what the duality of wave particle is. That's the concept of wave particle duality is. Now coming to the limitation part of classical physics. So in classical physics, particles were thought to be like a tiny ball. You can say एक bouncy ball आती थी, एक छोटी सी रबर की होती थी बचपन में. So in classical physics, particles को माना जाता था कि वो they're much like a tiny ball. And waves were seen as continuous spread of energy. और waves को कहा जाता था कि they are continuous spread of energy, कि वहां पर जो energy का spread है it's continuous. So originally electrons were thought of as a small solid object, और light को क्या समझा जाता था? Just as a wave. But this issue got resolved, this limitation got resolved by showing that these particles like electrons, photons, they do not fit neatly into the classical categories of wave or practices. Sorry, they do not fit neatly into the classical categories of wave or particle. They do not. So we have understood this in the de Broglie concept of matter waves also, where we have proved this. We have noticed that particles like photons, electrons, they can display properties of both particle and wave nature depending upon the situation. I hope आपको इतनी simple words में notes लिखे गए हैं कि just by reading this also आपको idea लग जाएगा कि what the concept is, what the basics are. So ये एक सिंपल सा क्वेश्चन था जो आपको पता होना चाहिए, द वेरी बेसिक of quantum mechanics, wave particle duality, and the classical limitation of understanding particle like electrons and photons. Let's move on to the next question. Next question is, what is the Heisenberg uncertainty principle? I hope आपने इसको 11th या 12th में कहीं ना कहीं अपने क्लासेस में जरूर पढ़ा होगा स्कूल टाइम में. Heisenberg uncertainty principle क्या है? Okay. Heisenberg's uncertainty principle is one of the most important results of 20th century physics and is one of the important concepts in quantum physics. So just a small information about Heisenberg uncertainty principle is that it's one of the most significant results of 20th century physics, or quantum mechanics is one of the most important topic also. And when I say that it's most important topic, definitely क्योंकि ये बहुत काम आता है in understanding these particles like electrons and photons. How? Let's understand. Heisenberg uncertainty principle, सबसे पहले तो ये किस बारे में है? ये कहता है कि certain pairs of measurement such as where a particle is and where it is going, like its position or its momentum, it cannot be precisely pinned down. इन शॉर्ट, आपको इसको आसान भाषा में अगर मैं बताने की कोशिश करूं तो ये है कि इट इज इम्पॉसिबल टू मेजर द एग्जैक्ट पोजीशन एंड मोमेंटम ऑफ अ मूविंग पार्टिकल साइमल्टेनियसली. अगर आप ये सोचो कि किसी पार्टिकल के बारे में हम कुछ पेयर ऑफ मेजरमेंट्स, कुछ पेयर ऑफ प्रॉपर्टीज के बारे में एक ही समय में एक साथ बता सकते हैं, तो ये इम्पॉसिबल है. क्योंकि जब आप एक प्रॉपर्टी के बारे में, उसके लेट्स सपोज दो प्रॉपर्टीज हैं, पोजीशन और मोमेंटम, जब आप उस पार्टिकल की पोजीशन को निकालने की कोशिश करोगे कि वो पार्टिकल किस पोजीशन पर है, then it's impossible for you to calculate or determine its momentum. And similarly, जब आप उसके momentum को निकालने की कोशिश करोगे, then it is impossible for you to calculate its position. And that's what Heisenberg uncertainty principle is. There is some level of uncertainty when you're going to determine, these kind of things. So certain pair of measurement, such as where a particle is, where it is going, it cannot be precisely pinned down. That's what the Heisenberg uncertainty principle is. In simple words, there is a limit to how precisely we can know certain pairs of properties of a particle at the same time. At the same time, simultaneously, there is a limit. Limit है कि हम certain pair of properties को कितना अच्छे से समझ सकते हैं. Okay? Now let me just give you an example. Imagine you have a tiny particle. Let's suppose that tiny particle is nothing but electron. So basically, Heisenberg uncertainty principle ये कहता है that if you try to measure this particles, that is electrons position very precisely, then you will be less certain about its momentum. अगर आप इस पार्टिकल इलेक्ट्रॉन की पोजीशन निकालना चाहो तब आपको, तो पोजीशन अगर आप निकाल रहे होगे तो उस समय आप मोमेंटम नहीं निकाल सकते. So you'll be less certain about its momentum then. And similarly, अगर आप उसके मोमेंटम को निकालने की कोशिश करोगे, at that time you cannot measure its position precisely. Basically, एक साथ एक समय में you cannot measure the pair of properties and there is a limit to it. If you're understanding or if you're determining one property, you will not be certain about the another property. And that's what the Heisenberg uncertainty principle is. Let me just give you an example again to, अगर अभी भी आपको clear नहीं है चीजें, to make it clear in your mind. Let's suppose you can imagine it, close your eyes and you can imagine it, you can think of as a car. You think of a car on a road. एक कार है, वो रोड पे चल रही है. Let's talk about two properties now, position and speed. तो हाइजेनबर्ग अनसर्टेनिटी प्रिंसिपल यहीं पर आप समझ जाओगे. तो कार चल रही है. नाउ इफ यू वांट टू नो द एग्जैक्ट पोजीशन ऑफ कार ऑन द रोड, कि भाई वो कार रोड पे किधर है, वेयर इट इज, सो यू हैव जीपीएस फॉर दैट, यू हैव मैप फॉर दैट. बट अगर आप फोकस करोगे ऑन पिन पॉइंटिंग कार्स एग्जैक्ट पोजीशन, तो उस समय उस एग्जैक्ट पोजीशन को अगर आप पिन पॉइंट करने की कोशिश करोगे, तो जिस समय आप उसकी पोजीशन को देख रहे हो, एट दैट वेरी टाइम you cannot measure how fast it's going, because you're not looking at how it's moving, you're looking at its car position. I'm talking about that exact second where you are trying to locate car's location. At that time it will be harder for you to measure how far it's going, because you're not looking at how it's moving. That's what the Heisenberg uncertainty principle is. Alternatively, let's suppose if you measure the car's speed very accurately, then at that exact time its precise movement, जब आप स्पीड देख रहे हो कार की, तो आप पोजीशन पता लगाना चाहोगे उसी समय में. नाउ अगेन आपको क्लियर आइडिया नहीं लगेगा, but you might know only its position roughly, not exact. So now the question is that why this Heisenberg uncertainty principle is like it's so important in quantum world. I during the starting of this question I just said to you कि it is one of the most important concept in quantum mechanics. अब आप खुद सोचो इतना important क्यों है ये quantum world के लिए. कहीं ना कहीं ये इसलिए important है क्योंकि ये दिखाता है कि these particles like electrons, photons, they don't have exact values for both position and momentum simultaneously. You can't predict कि exact values होंगी. You cannot understand this कि कोई particle जैसे electron, photon, ये किसी moment पे इनकी speed क्या है और ये कहाँ होंगे. और ये ऐसा इसलिए नहीं, आपको ये बात समझनी होगी कि ऐसा इसलिए नहीं है कि हमारे मेजरमेंट टूल्स में फ्लॉज हैं. दैट्स अ वेरी नेचर ओनली. ये इनका नेचर ही है. दिस इज अ फंडामेंटल फीचर ऑफ हाउ दीज पार्टिकल्स बिहेव एट टाइनी स्केल्स. सो वी कैन नॉट मेक दिस कि भाई ये चीज हमारी फ्लॉज है, दैट वी आर नॉट एबल टू अंडरस्टैंड द एग्जैक्ट पोजीशन एंड मोमेंटम एट द सेम टाइम. दिस इज नॉट आवर फ्लॉ. This is the very nature of these particles, these tiny particles. So it tells us that there is a built-in limit only that how we can know about a particle's position and momentum at the same time. और क्वांटम लेवल पे हमें मदद भी मिलती है इन पार्टिकल के बिहेवियर को समझने में. ओके, सो आई होप आपको क्लियर है अबाउट व्हाट इज हाइजेनबर्ग अनसर्टेनिटी प्रिंसिपल. Okay, let's talk about the mathematical formula for Heisenberg's uncertainty principle. Let's suppose delta x here is me. Delta x here is standard deviation of position. So let's suppose delta x is standard deviation of position. Similarly, let's say delta p is standard deviation of momentum. Okay, so delta p is the standard deviation of momentum. Then the product of the uncertainties in position and momentum, it is linked to the width of wave functions in both spaces. We all know wave function is nothing but in quantum mechanics. In order to understand about these particles, the delta x, the position, the momentum, we represent it through wave function psi. Okay, this is what the wave function is. Okay, psi, इसको हम psi बोलते हैं. This is going to be your wave function. So basically, what I just said, that the product of the uncertainties in position and momentum, it is linked to the width of the wave functions in both spaces. That is, delta x to delta p is greater than equal to h upon 2. Actually, h bar upon 2. And this h bar is nothing but reduced Planck constant. So this is reduced Planck constant. And its value is not 6.6 into 10 to the power minus 34. Instead, it is 1.055 into 10 to the power minus 34 joule second. So that's what the mathematical formula of Heisenberg uncertainty principle is. Here, this h is nothing but it's reduced Planck constant. So the product of the uncertainties in position and momentum is linked to the width of the wave functions in both spaces. Let me write it again for you. So delta x to delta p, that is the product of the uncertainties in position and momentum, is greater than equal to h bar upon 2. That's what the mathematical formula for Heisenberg uncertainty principle is. Remember, this h is reduced Planck constant and its value is this. Its value is this. Okay, let's talk about the next question. Very important question. Define the Schrödinger equation. Also explain its significance in quantum mechanics. सबसे पहले तो आपको Schrödinger equation को define करना है. Do you know what Schrödinger equation is? Not a problem. Let me tell you with an example. ध्यान से सुनो, अभी स्लाइड मत देखो, चलेगा. Schrödinger equation, you can say it's like a recipe. You know, recipe जानते हो आप? किसी चीज को बनाने के लिए you have different recipe. In order to make kheer, you have recipe. You have different ingredients that you have to collect, and then you have to mix, and you have to cook, and then it's ready. Okay, it's kind of a recipe. So Schrödinger equation, it's like a recipe only that tells us that how these tiny particles like electrons, they how they behave and they change over time. So यहाँ पर टाइम जो है ना, टाइम बहुत इंपॉर्टेंट प्ले जो है रोल जो है कहीं ना कहीं प्ले करता है, क्योंकि स्क्रोडिंगर इक्वेशन इट्स नथिंग बट इट्स लाइक अ रेसिपी that tells us how a tiny particle such as electron behaves and changes over time. जैसे we individual, we also behave differently in a different ages in life. Like for example, when you were 15 years old, you behave differently, and now you're maybe 20, 22, 23 years old, you'll behave differently now, because आप में भी बिहेवियरल चेंजेस होंगे और बहुत सारे चेंजेस होंगे, फिजिकल चेंजेस होंगे, बिहेवियरल चेंजेस होंगे, साइकोलॉजिकल चेंजेस होंगे, एक्सपीरियंसेस आए होंगे, एंड दे ऑल मेक यू change, gracefully, or maybe you change disastrously. So anything can happen. So what I'm trying to mean here is कि स्क्रोडिंगर इक्वेशन कुछ भी नहीं है, बस इतना ध्यान रखो, ये हमें ये बताती है कि इलेक्ट्रॉन्स, फोटॉन्स, ये जो टाइनी पार्टिकल्स हैं बेसिकली क्वांटम वर्ल्ड में, ये किस तरीके से बिहेव करते हैं और ये विद टाइम इनमें क्या चेंजेस आते हैं. So it's a special kind of math, wave function basically, कि यहाँ पर हम हेल्प लेते हैं ये प्रेडिक्ट करने के लिए कि किस तरीके से कोई पार्टिकल मूव करेगा विद टाइम, किस तरीके से कोई पार्टिकल मूव करेगा, मोशन किस तरीके से होगी उसकी, वेयर द पार्टिकल इज लाइकली टू बी. So this equation is really very crucial for understanding the weird and wonderful world of quantum mechanics. So we can say that okay, it basically tells us where the electron is, its position basically, and how it behaves and changes over time. Okay, as for that we use wave function. Okay, and just now I told you the wave function kya hota hai. Let me just tell you again. That's how we represent wave function as. This is your wave function. ओके इसको हम बोलते हैं साई. क्या बोलते हैं? साई. ओके, वेव फंक्शन है ये आपका. ठीक है, सो आई होप यू आर क्लियर विद इट. ओके, सो लेट्स अंडरस्टैंड. सो वेव फंक्शन आपको क्लियर है ना? बेसिकली इट्स अ वेरी कॉम्प्लेक्स फंक्शन. उसमें दोनों रियल और इमेजिनरी पार्ट्स होते हैं और it depends upon the position and time. So in order to understand these particles, these smaller particles, we uh, take help of this wave function here. Basically we usually represent these particles, electrons, their position or where they are, or with the help of wave function. Okay, the square of the wave function's magnitude, it gives us a probability of finding the particle in a particular position at a particular time, and we'll talk about it in few minutes in one of the question. कि जब आप इसका square कर लेते हो, the square of this wave function, so the square of this wave function and its absolute value at any point x will give you the exact probability, or will give you the probability of finding the particle in a particular place. So it will give you the probability of finding the particle. So the particle is most likely to be in that position where its value is high. So जहां पर इसकी वैल्यू हाई होगी वहां पर ही आपको पार्टिकल की पोजीशन देखने को मिलेगी, और इसकी वैल्यू जहां पे लो होगी वहां पर आपको कम देखने को मिलेगा पार्टिकल को. Okay, so let's understand now about Schrödinger equation. So Schrödinger equation is a fundamental concept in quantum mechanics that describes how the quantum state of a physical system changes over time. Basically, how these tiny particles behaves and changes over time. The state of a particle like electron is described by mathematical function called wave function. So we already know in quantum physics, in quantum mechanics, in order to understand about these particles, smaller or tiny particles or their state, we usually describe it by a mathematical function called wave function. Okay, in quantum mechanics, which really sorry should be, it should be quantum mechanics here, so you can correct it and make it quantum. Okay, sorry about that. Okay, so called wave function in quantum mechanics, which contains all the information about the particle such as its position and momentum. Basically, this Schrödinger equation is nothing but it's a mathematical equation that describes how the wave function evolves over time. तो ये क्या बताती है बेसिकली कि किस तरीके से कोई वेव फंक्शन इवॉल्व करता है ओवर टाइम. ऊपर ऊपर से देखें तो किस तरीके से कोई इलेक्ट्रॉन बिहेव करता है ओवर टाइम, क्योंकि इलेक्ट्रॉन की ही बारे में जो हम समझते हैं, हम इलेक्ट्रॉन की पोजीशन को, बेसिकली इलेक्ट्रॉन की स्टेट को और इन पार्टिकल्स की स्टेट को ही हम वेव फंक्शन की मदद से रिप्रेजेंट कर रहे हैं. सो व्हेन वी से that it describes how the wave function evolves over time, it means what we are trying to mean here is we try to describe how electrons evolves over time, which means it is two aspects. दो एस्पेक्ट्स इसमें शामिल हो जाते हैं जब हम इसकी बात करते हैं. एक होता है टाइम डिपेंडेंट, एक होता है टाइम इंडिपेंडेंट. नाउ लेट्स टॉक अबाउट दीज टू एस्पेक्ट्स. Let me just remove these things quickly and let's talk about the two aspects, the very important two aspects in Schrödinger equation. Okay, yes, okay, so Schrödinger equation mein, just now I've told you there are two cases. First is time dependent and another is time independent. Let's talk about time dependent. एंड इट इज क्लियर विद द नेम, आपको समझ में आ गया होगा यहाँ पर कि टाइम डिपेंडेंट का मतलब क्या है। यहाँ पर टाइम डिपेंडेंट का मतलब है कि व्हेन क्वांटम स्टेट चेंजेस विद टाइम, व्हेन द वेव फंक्शन इट चेंजेस विद टाइम, टाइम के हिसाब से अगर वेव फंक्शन में चेंज आ रहा है या क्वांटम स्टेट में चेंज आ रहा है, देन इट्स गोइंग टू बी अ टाइम डिपेंडेंट स्क्रोडिंगर इक्वेशन। तो इस केस में यहां पर एक इमेजिनरी पार्ट भी शामिल हो जाता है, ये आई है यहाँ पर, डोंट जस्ट गेट कंफ्यूज्ड। सो यहाँ पर इमेजिनरी पार्ट भी शामिल हो जाता है, आई एच बार, देन द पार्शियल डेरिवेटिव ऑफ वेव फंक्शन विद रिस्पेक्ट टू टाइम। So partial derivative of wave function with respect to time, and that is equal to Hamilton operator and wave function. This is going to be the equation for time dependent Schrödinger equation. This is time dependent Schrödinger equation basically. That is when quantum state changes with time. Okay. Now this is going to be the imaginary unit. So this I represents imaginary unit. Then this you already know, this is h bar, this is imaginary unit, this is h bar, that is reduced Planck constant value, also you are aware. This h is nothing but Hamilton operator. So this h is nothing but Hamilton operator. What is Hamilton operator? Hamilton operator basically it gives you the total energy of system. That is, किसी भी सिस्टम की टोटल एनर्जी कैसे निकलेगी, उस सिस्टम की काइनेटिक एनर्जी प्लस पोटेंशियल एनर्जी को जब आप ऐड कर दोगे, सो दैट्स व्हाट योर हैमिल्टन ऑपरेटर इज। सो ये जो है ये बेसिकली आपकी टाइम डिपेंडेंट स्क्रोडिंगर इक्वेशन है। लेट्स टॉक अबाउट टाइम इंडिपेंडेंट स्क्रोडिंगर इक्वेशन। नाउ लेट्स टॉक अबाउट टाइम independent Schrödinger equation. So when we talk about time independent Schrödinger equation, so यहां पर इसका मतलब है कि क्वांटम स्टेट बेसिकली इट डू नॉट चेंजेस विद टाइम, टाइम के हिसाब से वो चेंज नहीं हो रही है। व्हाट डज दैट मीन? इट मींस कि बेसिकली यहां पर वो स्टेशनरी स्टेट में होगी, वो स्टेशनरी स्टेट में होगी। दैट मींस हियर इन दिस केस this Hamilton operator of wave function will be equal to the energy of a system and wave function. That's going to be the time independent Schrödinger equation. Okay. So now you need to understand this thing. So you have understood this time independent Schrödinger equation and time dependent Schrödinger equation. Now by solving these equation, we can determine the wave function, that is the psi here, and that will give you the probabilities of where the particle might be and how they interact. So the sum up part is this, that this Schrödinger equation is important. It is really important concept. It's really important equation because it tells us how these quantum system will behave over time. That's a basic concept of Schrödinger equation. Let's talk about the next question. Describe the concept of quantum superposition. And the second part of the question is, how does the principle of superposition apply to the energy states of a particle in a potential well? चलो इस क्वेश्चन को समझते हैं। सबसे पहले हमें ये समझना है कि भाई क्वांटम सुपरपोजिशन क्या होती है। What is quantum superposition? Quantum superposition is a concept in quantum mechanics that says a tiny particle like an electron can exist in multiple states or places at the same time. You know, there's a beauty in studying quantum mechanics. When you study these tiny particles like electrons, photons, you'll understand and you'll observe that how strangely these particles behave. Quantum superposition is nothing but it's just a concept in quantum mechanics that tells us about these one of the behavior of these tiny particles like electron can exist in multiple states or places at the same time. ये देखा गया कि जो इलेक्ट्रॉन है वो एक ही टाइम में at the same time it can be seen at multiple states or places. दैट्स व्हाट क्वांटम सुपरपोजिशन इज. इट्स लाइक कि भाई जैसे आप सिक्का उछालते हो फॉर हेड और टेल, आप टॉस करते हो. So let's suppose you're spinning a coin in the air. So there it is not about head or tail, but both at once until you catch it. तो जब आप spin कर रहे हो in the air, at that time it's not just about head or tail, but both. But जैसे ही वो आपके हाथ में आएगा, you'll catch it and you'll look at it, it's either head or tail. So in the quantum world also, particles, they stay in this mixed state of possibility. You cannot be sure of measuring their exact position where they are, their exact state at exact state of time, at exact moment of time. You cannot. They are always in a mixed state of possibilities until we measure them, forcing them to pick one definite state. So the idea is, to understand the strange behavior of particles, at the smallest scale. That's what quantum superposition is. That a tiny particle, it can exist in multiple states or places at the same time, until you're measuring them. So until you're measuring them, it's always work on possibility. When you actually measure them, that is, at that time what you're doing, you're forcing them to pick one definite state. सो बेसिकली ये जो प्रिंसिपल है ये कहता है कि ये जो पार्टिकल्स हैं, इलेक्ट्रॉन्स हो गए, फोटॉन्स हो गए, ये मल्टीपल स्टेट्स में हो सकते हैं, मल्टीपल पोजीशंस में हो सकते हैं एक साथ, until it is measured or observed. Okay, so for example, in a superposition, an electron can be in two places at once or have different energies at the same time. तो सुपरपोजिशन में ऐसा हो सकता है कि जो इलेक्ट्रॉन है वो एक ही समय में दो पोजीशंस पे हो सकता है with different levels of energy. But when we actually measure it, the particle chooses one of these states. That's what the concept of quantum superposition is. Okay, I hope you got an idea about it. Now the second part of the question is, how does the principle of superposition apply to the energy states of a particle in a potential well? Okay, let's suppose, imagine a particle. You can imagine a particle, trapped in a tiny box. और उस tiny box को, जो छोटा सा box है, उसमें आपका particle trapped है. Let's suppose electron is trapped in a tiny box, और वो box जो है उसको आप नाम दे दो potential well. That's what the question is, कि how does the principle of superposition apply to the energy states of a particle in a potential well? So let's suppose the particle is trapped in a tiny box, और उस box का नाम है potential well. So just now, according to the principle of quantum superposition, I've told you कि particle can have different energy levels. Particles के different energy levels हो सकते हैं. ओके, लेट्स सपोज आप अपने स्टेयर केसेस चढ़ना शुरू किया, ठीक है, आप 2 फ्लोर पे चढ़ना शुरू करोगे, तो व्हेन यू आर एक्चुअली ड्यूरिंग द फर्स्ट 2 स्टेयर्स और फर्स्ट 4 5 स्टेयर्स, यू हैव गुड लेवल ऑफ एनर्जी, आपका एनर्जी लेवल अच्छा है. बट जैसे जैसे आप ऊपर चढ़ते जाओगे, आप ऊपर वाली सीढ़ियों में आते जाओगे, आप सेकंड फ्लोर तक पहुंचते जाओगे, क्या होगा, एनर्जी लेवल कम होता जाएगा. Similarly, particles can also have different energy levels. Okay, so according to the principle of superposition, जो particles होते हैं, they are in a mix of these energy levels at the same time, not just one specific level. Okay, but they are in mix of different energy levels at the same time. It's like if you were, standing on several steps of a staircase at once, like that. So when we measure the particle's energy, it chooses that one of the possible energy levels. Until we measure it, the particle exists in superposition of all its possible energy state. That is, simultaneously it occupies multiple energy levels, creating a combination of all these states. So that's how it is applied to the energy states of a particle in a potential well. So when we measure the particle's energy, It chooses one of the possible energy levels, and until we measure it, the particle exists in superposition of all its possible energy states. Okay, so simultaneously it occupies multiple energy levels, and it creates a combination of all these states. Okay, so that's how we can apply the principle of superposition to the energy states of a particle in a tiny box, so let's say potential well.